So let's continue with the same thing. Okay, if this plus 9q and minus q are fixed, so you can place either over here and also over here. You do it in your homework. Okay, suppose if I place a positive, say q dash, I know what is the value of q dash. Okay, you need to know how you find the value of q dash. You need also know it's d. So don't worry, 1 by root q dash plus 1 by q 9q is equals to 1 by root q. By this you can find the value of q dash. Now you have to check if I displace this in this way by a small distance x, what sort of equilibrium is this? Okay, you have to do it in homework, and in the doubt clearing session I will check this one out. Okay, in the doubt clearing session I will check this one out. Okay, so let's move on to the next topic. Okay. See, this topic will work as many support for many topics. This topic is maximum force. Now, what is this maximum force? Suppose if you place plus q over here, say this is d, say this is d. If I place a negative q over here, if I place a negative q over here, this will be attracted over this way and this will be attracted in this way. And what is the net force? The net force is something like this. And say this distance is equals to x. This distance is equals to x. And we have already seen an F net comes out to be what? It comes out to be 2k big Q small q x by d square plus x square to the power 3 by 2. You have to keep this expression in mind. Keep in mind this is d, and if the total is d, then this becomes d by 4. This becomes d square by 4. Okay. Now, again sir, for F net, F maximum. Sir, maximum depends upon the separation between these 2 points. Means F max, for F max, what need to do? df by dx is equals to 0. Now we need to solve it. Now I need not to solve it. I know you can do it at home. You can do the differentiation and we will get df by dx is equals to 0 at x is equals to d by root 2. At x is equals to d by root 2. When x, the value of x is equals to d by root 2, you will get the maximum attractive force. And yes, this is not SHM. This will be simple oscillation. So it is simple oscillation, but not SHM. It is simple oscillation but not SHM. Keep in mind, simple oscillation. And if I need to find the F maximum, what do? You put the value of x over there, you get 2k big Q small q d by root 2. See the style I am doing. It is d square by 2. D square by 2 means 3d square by 2 to the power 3 by 2. To the power 3 by 2 means what? To the power 3 by 2. Check it out. That means this 2 goes cancel off. Okay, chalo. I write it in a different format. Okay. Okay, I write it in a different format. How I write it? Check this thing out. This d, acha. First, just check it. 3 by 2, root over 3 by 2. I don't know how many of you have got this thing. Let me explain you. 3 by 2 to the power 3 by 2 means 3 by 2 to the power 1, 3 by 2 multiplied to the power half. Simple. Okay, so this root 2 goes cancel off. This 2 goes over here as 4 and this 3 root 3. So 4k big Q small q by 3 root 3 into d square. This is F maximum. This is F maximum. So this is by far one of the most important topic which we will apply in many cases. We will see to it. So you have to keep in mind this expression. Please don't, you can derive it, but I hope so once you practice it, this expression will already be in your brains, okay? And for what it is maximum, no need for differentiation. If this is D, this is D, then the maximum occurs at D by root 2. Then maximum occurs at D by root 2. We even have a graph. Something like this. See, if I say the mod of the force means the magnitude. I am not talking about the direction. It is coming down. So at this point, the force is 0. Okay, at this point the force is 0. See, at this point the force is 0. As we go away, we got a maximum. Where is the maximum? D by root 2, and in this case minus D by root 2. And what is the value of the maximum force? The value of the maximum force is this. So this holds a most important thing for your competitive examination. This generally don't come in your boards. This expression generally don't come in your boards. This expression do comes in your competitive examination. In NEET basically they know students do memorize this expression. They ask for this thing. In JIPMER also there is a question about this point. Exact this question we have in JIPMER. Okay, so this topic is important. So let's move on to the next topic. Okay. Now, revolution of a charge about another charge. Revolution of a charge about another charge. Okay. So, what I say, let's say this plus Q, okay, my blue ink is over. I have to manage it with blue and red. Like that. Plus Q, say this is fixed. Say plus Q is fixed. And I am, say at a distance C, a minus Q. Say the question says minus Q is set into rotation. So the mass is small m. The mass of the body is small m. The minus Q is set into rotation. Okay. So what we need to find? We need to find the time period. How? So simple as that. What is the attractive force? K big Q small q by d square, and this is equals to, you have learned m omega square d. I think you have known this is a centripetal force, and we need to find the time period, and that is equals to 2 pi by omega. So omega square is equals to k big Q small q by d cube. Time period becomes 2 pi. So this is root, and when it goes up, it is d cube by k big Q small q. I have missed one m. I have missed one. This is the time period of rotation of this thing. Now we move on to another topic of three charge system. Now they are not in the line. Okay. Now what we do? We say Q, 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 Q. The three charge system. Okay, let us say they are separated by a distance d. What you have, you need to find the net force on any of the charges. Is at this instant. Find F net on any one of the charges. Find F net on any one of the charges. Suppose I take this thing, so sir, this plus Q will be repelling this plus Q in this direction, this plus Q will be repelling, say F and F. See, we use a technique. What is the technique? So F is equals to K Q square by D square. Hello, yes sir, this is done. And the angle between them is 60 degree. Okay, how 60 degree, that we don't know, it's magic. Okay, so let's say this is X. Let's say this terminal is X. Two force X and X inclined at 60 degree. If you have done the chapter of vector, the F net will be equals to root 3 terms of X. The F net becomes what? Root 3 terms of X. So it becomes how much? Root 3 terms K Q square by D square. And where it is aligned? So it is aligned something like this. F net is along the perpendicular bisector of these two lines. F net is along the perpendicular bisector of the two lines. Okay. So this is a small thing. So this is not yet complete. Though this is not yet complete. This is an incomplete sum. So now we will do the complete over here. So I think these two are clear. Okay. So let's proceed on to the next one. Now the question says, what charge must be placed at the middle? See, it's a very common thing. Sir, how to know whether there is any possibility of equilibrium or not? I will say also. Suppose, check this thing out. This is a beautiful concept. No, very few people know about this thing. Very few. You draw the three lines of F net on each charges, okay? See, this is having F net in this direction, this is having F net in this direction, this is having F net in this direction. Check it out. Every charges is having F net in this direction. Now, if the three things coincide at a point, then there is a possibility the system can be in equilibrium. Possibility, okay? So over here, yes, they are all of same magnitude and they are all coinciding at one point. What charge must be placed at the middle so that the system is in equilibrium? Now I talk about the systems. Now in this case, every charges has the tendency to move away. See, every charges has a tendency to move away. So what we need to place? Sir, we need to place a negative charge at the middle so that the negative charge can hold the positive charges and negative charges as well as be attracted by all the three charges. So check the arrangement: plus, plus, plus. You place a negative charge at the middle and this negative charge is being attracted like this way. See, it will also be attracted by some forces, say F dash in each direction. And all the forces are inclined at what degree? Inclined at 120 degree. So this minus Q is itself is in equilibrium. Now we need to check for the equilibrium of any of the charges, what will be the value of the minus Q. So how to do? Sir, over here we place a minus Q. Acha, can anyone tell me what is this distance? Yes sir, this is very easy. This distance is nothing but we say 2/3 of all T. We have a code name 2/3 all T. And what is all T? Altitude is what? Altitude is √3 by 2 times of the side. Altitude is √3 2 times of the side. So what it comes out to? It comes out to 2/3 into √3 by 2 into D. That comes out to D by √3. So now this minus Q will attract each and everyone with this distance. Yeah, let's show us. I am taking any one of the charges, anyone. This was experiencing a force F net in this direction, and this will attract with F dash. Why F dash? Because if the minus Q is being attracted by F dash, then minus Q will also attract it by F dash. So F dash has to be equals to F dash has to be equals to F net. F dash has to be equals to F net. So what is F dash? Kindly have a look. K, big Q, small q. And what is the distance separating them? What is the distance separating them? D by √3 whole square. D by √3 whole square. And what was F net? F net was √3 k q square by d square. √3 k q square by d square. Now have a check. This √3 whole square becomes 3. This 3 goes above. 3, 3 cancel off. √3 cancel off. So this small q comes out to be q by √3. The magnitude comes out to be q by √3. But it is negative in nature. It is negative in nature. So this is one of the most important topic. No, we have something else also. We have something else also. So I hope so this is clear. I hope so this is clear. Okay. So please have a look. Right now I must end lecture 3. All the today's thing up to this. Lecture 4 will be coming. So keep in mind this, all the portions are very important. Okay. We will do many numericals in lecture 4 because we have already done the basics of the equilibrium of forces. What are the forces, how they work vectorially. Next we will be doing the field concept and the numericals. Okay, so here we end with lecture 3.